Good afternoon, everyone, and thank you for attending our Reducing Risk in Your Custom Cable Assembly webinar. My name is Keith Rujo, Director of Marketing here at Epec. Before we get started, I just want to let you know that you will all be muted during this presentation. If you have any questions as we move along, please enter them into the questions panel located in the webinar control panel. We'll try to get to all the questions at the end of the webinar, but if we don't have time to go through all the questions, we'll make sure that we reply back to everybody via email. We will also be recording this webinar and posting both the recording and the slide deck on our website and YouTube channels. Our presenter this afternoon is Stephen Goodman, our User Interface and Cable Assembly Product Manager. Stephen is a mechanical engineer with a Bachelor of Science and MBA, both from Northeastern. Before joining Epec back in 2017, Stephen had run a manufacturer's rep firm servicing various companies in the aerospace, defense, and industrial markets, helping them develop new products. As the User Interface and Cable Assembly Product Manager here at Epec, Stephen works closely with customers to provide solutions to specific problems during design consultations and, where needed, helping customers with the creation of specific designs. So without further ado, I will pass it over to Stephen.
Thank you, Keith. Good afternoon, everybody. My name is Steve Goodman, and I'm one of the product managers here with Epec. This afternoon, we'll be covering ways to reduce risk for your custom cable build. Our agenda today will cover ways to manage risk, some specific design options to reduce risk. We have a few case studies we'd like to show you specific to charging cables. Next, we'll talk a bit about how to get started with your custom build, and then wrap up with a summary and questions. So first, what is risk for your custom cable? As Wikipedia defines it, risk is the possibility of something bad happening. Typically, risk focuses on something negative or some type of undesirable consequence. In terms of the impact to your business, it really depends on the impact and the type of event that may occur. But it's important to understand the level of risk and what the impacts are, so it's able to be effectively gauged and mitigated. Generally speaking, there's three types of risk that we're going to focus on today. Those are design, cost, and sourcing risks for your custom cable assembly. So first, what is risk for your custom cable? There's a lot of things that can happen in manufacturing, and this list certainly is not everything. But it can be anything from some type of inadequate design or an assembly step. There could be some type of challenges with the shipment or handling of your cable. It could be something as simple as a modification or rework to a tool that you're using in the build. Risk is also the impact of end of life or component obsolescence. Any types of delays or issues with your design approval also will manifest themselves as risk for your project. A supplier's going concern. It's assumed that all of your suppliers will remain in business indefinitely, but what happens if one of them stumbles and encounters financial challenges? Quality, workmanship concerns, etc. These are all things that can happen during your custom cable build. Other types of risk, such as your connectors not mating properly, aren't going to be able to be determined until after you've built and shipped and you go to assemble your product. Other types of risk obviously include some types of tariffs, import duties, and all the way to some type of qualification failure that you experience during development and testing. Ultimately, risk can never be eliminated and it only be managed. So first, design risk. What is that and how does that impact your custom cable build? Generally, this would be the inability for your hardware to satisfy the program objectives. But what does that mean? There's a lot of things that happen in development. Typically, timelines are tight, you're on a budget, things happen. Along the way, requirements can change. This can be something subtle and happen over the course of a few weeks, like scope creep, where slowly but surely small design features are added, and eventually the schedule and costs are no longer what they originally planned to be. Some of these are pure customer-driven changes, such as a complete change in the design, the color, a connector. All of these things manifest themselves as design risk. But other things like operator error can occur. The wrong part can be crimped. The wrong connector can be ordered, or a part number could be mixed on a design proof. All of these things happen. Lastly, it can be something as simple as an inadequate or incorrect part number being originally specified, and then when that part's tested, it doesn't meet the design objectives. So overall, ways to manage design risk include several things that engineers and buyers do daily, but in-process inspection and design reviews are some of the best ways to manage design risk for your project. The next type of risk is cost risk. Basically, does the projected costs of the program and how do they compare to the original budget? So this could be something as simple as the raw materials price is increased, or purchase part materials price increase. There can be things like minimum order quantities or lot charges that are not completely understood that then impact the program later on. Suppliers make errors in their quotation. Maybe they missed a drawing or assumed something that wasn't clear. But all of these things can in some way impact the overall cost and budget of the project. The best way to manage this is advanced planning. The next type of risk we'll talk about today is sourcing risk, and that's literally the movement of material to and from suppliers and manufacturers. But this can include both shipment and transit of materials. This can also include a company's reliance on a third party, like a stocking distributor or some other partner in your supply chain. Another thing with sourcing risk that's critical is what the impact is on free trade agreements. Currently, there's tariffs that we encounter daily. These are things that need to be understood clearly at the beginning of any project. Next, we'll talk about some specific tips to manage risk for your custom cable. So the first step to managing risk with your new project is getting ahead of this at the quote stage. The first question to ask yourself is the documentation that you're providing to your potential supplier, is that documentation clear? If there's any ambiguity in that, you're leaving yourself in a position of risk. The next step is to clearly understand the quote and compare that to the scope of work that you've requested. Once you actually receive the quotation, it's important to study that and understand if there's any custom tooling involved, if there are non-recurring expenses or NRE, or are there discrete engineering fees? For some projects that require a custom overmold, there is design work involved to develop the complicated tooling to build that part. Some suppliers assume that you, the customer, are providing that information. So it's important to ask these questions early on in the project. Lastly, because of our global supply chain, some projects have applicable tariffs. It's important to understand if the tariff applies and how much it is and when it's due. The next point in your design process to be able to better manage risk is during the design freeze. Now, with any development project, there's several steps that have to occur along the way. Typically, engineers will create some type of sketch or drawing that'll be reviewed and matured, and eventually all of that will arrive at a final production drawing that will be used to produce the parts. And depending on the complexity of the cable, some customers and suppliers may not even require a drawing to do that. If risk is a concern and cost and timelines are critical, push for a drawing at the front end. Make sure that your scope of work is clear. You want to remove all doubt in the definition of your part. Another tip during this design freeze point is to include some type of schematic or pinout for your custom cable assembly. Some drawings, it's simple enough just to identify what pin 1 is. And from there, you can deduce the rest of the pinout configuration. For complex or more non-standard type applications, it's recommended to have a complete pin assignment chart as shown on the sketch here in the upper right-hand corner. Lastly, most cables come with the assumption that continuity is tested. This is standard. Obviously, the cable needs to electrically pass current to be functional. Continuity is typical. But if your project requires testing above and beyond this, like an IP67 waterproof test or some kind of pull or flex test, these are important test specifications that must be clear early on to your supplier. Otherwise, you can run into risk either during development or after shipment, finding out that your widget doesn't actually meet the design objectives. Next, we'll talk about some specific options that you can use today to reduce risk on your custom cable assembly. The first step to reduce risk that we can recommend would be to carefully study your design and understand if you can get away with a single conductor or a multi-conductor cable. And why this is important is because many multi-conductor cables, as shown in the bottom right here, are not standard. They're custom extrusions, and there's minimum order quantities associated. This creates a cost and lead time impact for your project. But if you need 10 prototypes and you need them quickly, and you're not sure if they're even going to work, there is very little value in spending the time and money for a custom extrusion if you're doing fit checks or some type of preliminary testing. Electrically, we can run a similar number of conductors and bundle them together to achieve a similar type multi-conductor construction. So this cable in the upper right and in the bottom right here, although they look completely different, they both use conductors that are bundled and run in a certain configuration to meet design objectives. So if this is a challenge for your project, one of the things that we would do to recommend a low-risk path forward is to build prototypes or samples in this single wire bundle as we've shown in the top right. And once we've proven out that that design both electrically and mechanically works, then it's time to invest in the custom extrusion of this multi-conductor cable in the bottom right. Another step to reduce risk for your project is to utilize house tooling. House tooling are overmold tools and fixtures that we have in place that are existing that we can use on your project. This photo on the right here is a M12 connector. The top is our house tool. The bottom is a sample that we received from a customer. Mechanically and electrically, these products are identical. However, you can see that the Epec house tooling includes the tapered strain relief to help both the bend radius and also has some grips overmolded onto the end there. But this is important because custom tools can cost thousands of dollars, and depending on their complexity, cost tens of thousands of dollars. So if your program is short for time and money, there are options we can use to help both cost and your timeline. These house tools are available for many different common connector schemes. These include all types of USB connectors, RJ45s, RCA jacks. Many of the standard household type connectors you see and use every day, it's likely we have an existing house tool for. Another tip to reduce risk in the design process is to carefully study the materials that you're using. So for example here, our sketch in the upper right here, material A is the wire jacket, material B is the overmold. And if you, the customer, dictate to the manufacturer what materials to use, and you're also driving something like an IP67 waterproof requirement, you may be actually doing yourself a disservice. So specifically, not all materials here, material A and B, will bond properly in a chemical sense that will allow for a proper seal. Now, obviously, the overmold will adhere to the jacket in some way, but it may not be the type of seal you need for whatever application you're doing. So this is important because when you're designing and developing these cables, working with a supplier, you can identify both the test requirements and materials early enough to have the discussion and understand the impact if for some reason these two materials are not compatible. The last design tip we wanted to show you here is how critical it is to have a detailed manufacturing process. Now, many of the custom cables we support, we look at an off-the-shelf connector that has a suite of documentation, crimp and assembly tooling, and everything in between to fully assemble and test that connection. But it's important at this point to clearly document what specific tooling is needed, because some of the crimp tooling, as shown down here, can be thousands of dollars and tens of weeks lead time. There is nothing more crippling to your project than spending the time and energy to design a custom cable, buying the connectors, only to find out you need a crimp tool and it's $2,500 with a 10-week lead time. So it's really important early on to understand the application, what's needed to build the part, and make sure that everything along the way aligns with the common goal of delivering a conforming part. Next, we'll touch on our two case studies here about charging cables. This first one is a children's nightlight. And in the upper right-hand corner, you can see it's just a polycarbonate window with some horizontal LEDs and a light strip on the bottom. And when this is plugged in, it turns on and keeps your child happy. This is powered by your 120 volt AC wall outlet, typical USB charger. We're energizing low voltage LEDs. Typically an application like this is 5 volts DC or less to excite them. And the type of cable that's connected here is typically a USB standard, but with this application here, usually just the power legs of that USB cable are used, and the data legs are either omitted or just blanked out on the connector. So one of the benefits to this type of cable is this is common, and we have house tooling readily available that we can use on this type of project. So from a cost and lead time perspective, again, these are all arbitrary numbers, but for the sake of the webinar today, it helps us understand the impact on customization and the levels of customization for your cable. So if you, the customer, are okay using our house tool with no modifications to that overmold, we can perform this project with zero cost NRE. That's $0 for you to create and build this custom cable from a tooling and NRE perspective. The overall timeline shown here is about 5 weeks from the time that Epec receives the request for quote till the time we actually ship. And it's important to note here that the actual quote preparation time is just a few days. That's because it's a low complexity, simple, and existing design. The next case study here is a beard trimmer. Also powered by 120 volts AC from your wall outlet. The difference here is instead of interfacing with a micro USB connector, this has a custom 2-pin connector here. The power here is coming into the beard trimmer, energizing a small electric motor. But what's critical here is that with the power cable side here, you have one custom connector, but you actually have to go and design and invest in the mating connector here in the upper right. While that may have benefits for the aftermarket if the user either breaks or loses their power cable, there's an opportunity for you to sell them a new one. It does incur a higher cost and development timeline on the front end. And that may be okay. Some of the benefits of that is you can add the additional level of customization, like these polarization marks here. So you know what pin connects to what point in the circuit. The other thing that can be done is actually full testing on your waterproof or splash-proof requirements. I can only assume that this thing's supposed to be able to survive a potential splash exposure. So with a custom mate like that, it gives you the opportunity to develop a waterproof connector design. In terms of cost and timeline impact, because there is the need to develop a custom tool to build these cables, and the fact that it's basically 2x the work, considering there's two connectors, excuse me, a project like this can take up to $5,000 of NRE. And that can vary, obviously, depending on the complexity of the tool. But instead of 5 weeks from the initial quote to delivery, this timeline here shows it would take about 8 weeks to ship this. The two big takeaways here is that one, something like this will take longer to quote, right? There's more steps involved. There's additional design expertise needed to review and cost that design. It's also more complicated. The other thing to note is the actual pure manufacturing time is longer as well, right? There's time to tool up, test the tool, make sure that it's satisfactory. If dimensionally there's a problem with the tool, there needs to be time built into your schedule to make modifications and reassess the change and make sure that your part is effective go forward. It's important to note customization is possible, but it adds cost and time. So overall, the Nightlight project we would deem as low risk. There's $0 in NRE to support the overmold tool. It's a relatively straightforward project. If time and your program budget are absolutely critical and you cannot miss your delivery date, we would recommend the lowest complexity, the lowest overall risk project. Whereas the beard trimmer, it has a higher NRE as well as a longer development time. And while we don't see this as an ultra high risk project, it does have some level of risk, right? The point here is customization is possible, but it will add time and cost to your project. Next, what are the steps to get started with your custom build? First, it's important to understand that no two projects are alike. There's differences in terms of the tooling and the application and the test actual requirements. But generally speaking, the overall timeline to create some type of production tool can vary from 2 to 6 weeks, and even longer depending on the complexity. But the way we go to market with all of our projects that require some level of customization is the first step in our process is to create some proof of concept that our engineering team and yours can come together on. The next step is to collectively review a 3D model. We prefer step format. We run SolidWorks, but we can certainly import any type of CAD file or model file you have. The next step in our development timeline would be to actually manufacture and ship you samples. The fit check portion of the timeline here is of utmost importance. That's where we want to make sure that the design fits both electrically and mechanically with whatever you're trying to do. And at this point, if there are changes that are needed, we can walk the procedure all the way back to the 3D model, study the design together, and come up with some type of solution. Lastly, once the fit check is proved appropriate and acceptable, we can release the project to full rate production. So if you are interested in a custom quote, come to our website. We will supply this cable assembly inquiry form to help us capture all the information required on the front end to get a quote completed in a timely fashion. The more information we have, the better. Some projects, because of their simplicity, can be just a few words describing the cable. For example, a 22-inch micro USB cable in red versus a complex squid-like harness or something to that effect. We would need some type of drawing or other documentation on. So, in summary, risk cannot be eliminated and only managed. And here at Epec, we have several steps built into our ISO approved processes that help identify and manage risk at all steps in our design, development, and delivery process. If you and your team are focusing on taking an active risk management approach, our recommendation is to focus on the design, the cost, and the sourcing risk of your project. Next, following suit on proactive ways to manage risk, attacking this at both the quote and design freeze stages allows you and your team the most likelihood for success in addressing any potential problems or pitfalls. Along the way, plan for design for manufacturability reviews. If you're molding an overmold and you need a very tight tolerance of, let's say, 5/1000ths of an inch, plus or minus, that needs to be identified early on in your project. Otherwise, that can manifest itself later on in the form of a potential delivery slip or a high scrap rate. And lastly, if you have a hard deadline for a shipment or a customer demonstration, keep it simple. Focus on existing designs that are proven, and hardware and components that are readily available in stock. And with that said, Keith's going to talk a bit about our products here.
Thank you, Stephen. So while we review some of the questions that came in, I wanted to briefly mention some of the other additional product solutions we offer here at Epec, such as our custom battery packs, our Flex and Rigid Flex PCBs, our circuit boards, which is our backbone, RF products, our user interface, which Steve also manages as the product manager, our flexible heaters, and our energy efficient fans and motors. So if you have any questions on any of these other products, you can feel free to go to our website and check out more information on what we offer here. And with that said, I will pass it back over to Steve to review some of the questions that came in.
Thanks, Keith. All right. First question here. Your slide shows 5 weeks for USB cable. We get these in a week or two online. How are yours different? So this is in reference to the micro USB case study number 1 that we showed here. And that 5-week timeline is a complete development for a custom part. So that includes working with the customer to create the specification, allow them to review the spec and approve it, sourcing all of the components that are required, and actually building the product. So I think the reality here is, in order to meet a 1 or 2 week timeline that these other guys are supporting, these cables are obviously either in stock or some kind of off-the-shelf cable. So the difference between Epec and these other online suppliers mentioned here would be ours are purely custom. Ours are purely built to print to the customer's specification to the purchase order. So we do not stock cables, which is, in my opinion, the only way that we'd be able to meet that 1 week or so turnaround time. Okay, the next question. If you're manufacturing overseas, does your lead time include transit time? Yes, it does. That's a great question. So the majority of our manufacturing is in Southeast Asia, and we consolidate and ship daily out of Hong Kong. That is one of the reasons how and why we're able to develop and manage these projects in such an expedited timeline, is we have daily shipments out of Hong Kong to our facility in New Bedford, Massachusetts. So yes, our lead time does include transit time. The quoted lead time that we provide you is from the receipt of order till delivery. Next question here is curious if you can talk about the best way to tolerance prints. So there's a lot of ways to tolerance cable drawings. I think generally the recommendation we give is to follow IPC 620, which has a very robust tolerancing scheme. When in doubt, we advise customers that plus or minus 10% the overall length of the cable is a appropriate tolerance. Obviously, if you have a 120-foot cable, I don't think that you'd need, plus or minus 12 feet of tolerance on that. So that would be something that could be shored up a little bit. But overall, we refer people to IPC 620 and advise about plus or minus 10% on the overall length. If your application has a critical dimension or a critical tolerance, these are things that we want to know and discuss back at the quote stage, and even worst case during that design freeze point. Next question we have is, can you quote from a spec? Yeah, I guess we need to know what a spec is in your context here, but generally speaking, a spec or a specification, we'd interpret that as some documentation that defines the part. And in order to quote that, we'd obviously need to know dimensional information about the cable, right? The overall length, does it have any breakouts? We'd want to know what the wire spec or wire size requirements are. And additionally, is there a bill of materials or any components that we're going to be assembling with the cable assembly? Next here is question. We've bought cables from you and paid a tariff. What happens if the tariff goes away? So what we do at Epec is we clearly identify on all of our quotations the potential tariff cost. And this is typically noted as a percent that applies to the production hardware only. It does not apply to the NRE or tooling or any of the engineering costs for labor, let's say. So obviously with the political landscape coming up in the next few years, this may be something that is changed. But to answer the question, if the tariff goes away, we would just simply remove that percentage noted on the quote, and it would not be applicable to your order. What's important though is the tariff is applicable upon shipment. So if product's already here and has already been received at Epec in our stocking warehouse here in the United States, that tariff is still applicable. That tariff is incurred upon receipt from outside the US into the US. So that is all the time we have. I want to thank everybody for attending our webinar this afternoon. And if you have any questions or additional information you're looking for, please contact us through our website or our sales@epectech.com email address shown here. Thank you, everybody. Have a great weekend.